Electrical current is nothing but flow of electrons from one point to another point. A conducting material like copper, tungsten, silver, etc. they do consist of large number of free electrons. Here in this diagram, black colored are nothing but free electrons. Some electrons are outside the atom and some electrons are inside the atom. The electrons which are outside the atom are nothing but called free electrons. If we consider a conductor with negative end and the positive end, negative end is of low potential and positive end of high potential. When we establish potential difference, electrons flow from negative terminal to positive terminal of the conductor. Consider a potential difference is applied across the ends of the conductor. So, electrons start flowing from negative end of the conductor to the positive end of the conductor. When we provide energy to the conductor, the atoms start vibrating and the free electrons start moving from negative end of the conductor to the positive end of the conductor. When these electrons flow in the forward direction, that is, they flow towards the positive end of the conductor, they cannot flow easily because the vibrating atoms come in the path of moving electrons, and this moving electron suffer head-on collision with the vibrating atoms. Thus, when the free electrons move in the forward direction, there is a collision between electrons and the vibrating atoms. Due to such collisions, the energy of electron is lost during drifting from negative terminal to positive terminal. This loss of energy gets converted into heat energy, vibrational energy, light energy, etc. When these electrons collide, they do not lose the total energy. A bit of energy is lost, and due to the loss of energy, either electrons flow with less energy and it changes its direction as well as. Thus, when electron flows inside a conductor, there are large number of opposition, and this opposition to the flow of electron is nothing but called resistance of the conductor. Opposition to current flow or opposition to electron flow is called resistance. Resistance of a conductor depends upon the following factors: arrangement of atoms in the conducting materials, type of chemical bond between the atoms, the quantity of free electrons, temperature of conducting material, length and thickness of conductor, area of cross section, that is physical state of the conductor. In 1827, a German physicist, George Ohm, performed a large number of experiments to find the relationship between the potential difference applied across the ends of the conductor and the quantity of current flowing through it. He put the relationship between the voltage and current and gave a theory called Ohm's Law. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across the ends of conductor, provided physical conditions of the conductor such as temperature, area of cross section, length, material, etc. are kept constant. This implies during the use of Ohm's law, we cannot change the length of the conductor, we cannot change the temperature has to be maintained at a constant, we cannot change the material, that means in place of copper you cannot use gold, or in place of copper you cannot use aluminum, or in place of copper you cannot use other material. If you are using one kind of material during the experiment, don't change the material, keep the same material during the experiment till you complete the experiment, don't change the material. Here we can use any material, any metal, like you can use copper, you use aluminum, you use silver, you use gold, any kind of material you utilize. Only during the experiment don't change the material. That is what I want to clear. According to Ohm's law, potential difference V applied across the ends of the conductor directly proportional to current I flowing through it implies V proportional to I. From this we get V upon I equals to constant, implies V upon I equals to R, implies V equals to R into I, or we can also write IR. That means voltage divided by current is equals to some constant, and this constant is called R. R nothing but resistance of the given material. Resistance is measured in terms of ohms. If we take potential difference applied between the two ends equals to 1 volt and current flowing through the conductor equals to 1 ampere, then voltage upon current, that is equals to 1 upon 1 equals to 1. Therefore R equals to 1 ohm. Thus 1 volt divided by 1 ampere equals to 1 ohm. SI unit of resistance is ohm. Since R equals to V upon I, implies 1 ohm equals to 1 volt upon 1 ampere. Thus 1 ohm can be defined as 1 ohm is the resistance of a conductor through which a current of 1 ampere flows when a potential difference of 1 volt is applied across the ends of the conductor. In this video, we got a unknown resistance and a current is flowing through the unknown resistance. Here the amount of current flowing and the potential difference across the unknown resistance are observed through the voltmeter and milliammeter. Suppose unknown resistance equals to 1 ohm. Under what condition it is possible? It is possible only if the voltage equals to 1 volt and the current flowing through the unknown resistance equals to 1 ampere. Now let us talk about variation of resistance with respect to temperature. For metals, resistance increases with increase in temperature. For semiconductors such as silicon, germanium, etc., resistance decreases with increase in temperature. For alloys like manganese, constantan, etc., does not change with increase in temperature. Therefore, manganese and constantan are used in making resistors. This is an experimental arrangement to prove Ohm's law. In this one, we got a unknown resistance. By using Ohm's law, we can easily find out unknown resistance here. Here, we got a voltmeter and milliammeter. and we also got a rheostat. By sliding the wiper of the rheostat, we can alter the amount of current flowing through the circuit. Here, when we perform the experiment by sliding the jockey slightly, step by step, and taking the readings. And while taking the reading, we note down the values of voltage and milliampere. And every time when we perform the experiment, voltage upon current will remain constant. By using this experiment, we can easily prove the Ohm's law. The relationship between voltage and current can be drawn with the help of voltage versus current graph. On x-axis, we take the voltage, and on y-axis, we take the current, and we plot the graph voltage versus current. We find that the graph is straight line. For metals, voltage versus current graph is a straight line. Thermistors, crystal rectifiers, vacuum tubes, they do not obey Ohm's law. That means for thermistors, for crystal rectifiers, and for the vacuum tubes, the graph is not a straight line. Dear student, my aim is to spread education among those students who do not go to colleges or do not go to tuition classes due to many other reasons such as financial or social reasons. I request you to spread this video among those students to spread education. I will come with another video with another topic. Till then, bye bye. See you. Meet you again.